The value question. Those who have studied our online e-text will be aware that notions of money and currency arrive rather late in the development of SF econ theory. Calculation of money prices was not made explicit until the model's physical and monetary states were brought together in our elucidation of efficient prices in a dynamic context. Being at pains to present a compact but informative price computation, these presentations required a severe compression of SF econ's actual mechanism for price creation. Specifically elided were our rather impertinent ideas about value, which we will now present as mediating between our model's physical and monetary states. Our intention here is to make the presently abstract notion of value literal in the sense of having a fixed unit of measure. Should this effort be credited, the auditor can look forward to subsequent videos wherein money is shown to reveal the economy's underlying value relations. Economics theorizing paladins have had their say regarding prospects for an absolute unit in which values might be measured, and they have been anything but encouraging. They should, nonetheless, be given some representation so that our rationale for ignoring their well-known counsel might be exhibited. Most famously, Mises intoned that it is vain to speak of any calculation of values. Calculation is possible only with cardinal numbers. The difference between the valuation of two states of affairs is entirely psychical and personal. It is not open to projection into the external world. It can be sensed only by the individual. It cannot be communicated or imparted to any fellow man. Professor Soule places objective value in direct opposition to economic activity. If there were an objective value, whether of goods or of labor, then economic transactions would make no sense. And Professor Sam Bostaff has favored us with an unsolicited email advising us as follows. Because utility functions cannot be quantified, and each acting agent has free will to change their subjective, unqualifiable preferences unpredictably, the SF econ model has no foundation in social reality, and can neither explain nor predict any economic phenomena. It certainly couldn't determine the value of anything, no matter what numbers it threw out. We receive these injunctions as logical deductions from what we regard as the malign premise of foundational microeconomics. In our video on this topic, to be found in the playlist titled Economics Fallacies, we agreed with the findings of behavioral economics to the effect that mainstream economics, reliance on individuals and businesses operating where marginal revenues equal marginal cost, has no empirical basis in Professor Bostaff's social reality. SF econ continues its adherence to marginalism based on our view of macroeconomic order as a naturally occurring, emergent phenomenon. This view was elaborated in our video on economic non-computability, also in the playlist titled Economics Fallacies. Herein it was suggested that the macroeconomy is best perceived as a causal system that is complete, entire, and closed unto itself, rather than as a passive collection of the discrete behaviors of some more elemental phenomena that, it is agreed, cannot be sensibly quantified. Macroeconomics is analogous to the hive, which is operationally altogether different from the bee. Our test of these convictions is whether or not we can quantify the utility functions for economic sectors as these are perceived for the purposes of macroeconomic analysis. One such test is outlined in our video recounting an empirical study, to be found in the playlist titled Mathematical Miscellany. Whether or not the R-bar squareds arrived at in this study should be sufficient to convince the chair of an econ faculty that macroeconomic production functions are quantifiable and likely to change in predictable ways, we will leave to the audience. We will be proceeding with our presumption that the production and utility trade-offs in which we expect to find operable expressions of absolute value are available for examination. SF econ locates value in what humanity knows about how to transform various physical things into other physical things. This knowledge is embodied in the design and extent of the economy's productive technology, in the levels of physical assets kept on hand to be transformed via this equipment, in the skills needed to operate and maintain these technologies, and in the provisions for sustaining those who perform the operations and the maintenance. Ultimately, we think of value as an atmosphere, an ether, the quintessence of relations among economic goods, economic processes, and economic beings, as these are directed together toward the specific, unique, and quantifiable outcome of general economic optimality. Noting that all the elements being related through the ether of value are tangible things having established invariant physical dimensions, we aspire to create an equally invariant, absolute unit of value. In our canon, value is not an ideal but regrettably unapproachable reference commodity. It is simply a unit of measure, like the troy ounce, the board foot, or the short ton. SF Econ presumes to continuously calculate an absolute value of every commodity, every currency, and every sector in terms of this value unit. Our value standard is named the Global Currency Unit, or GCU, because SF Econ's international financial settlements occur in terms of this abstract reference commodity. Economic subject matter imposes a special challenge upon attempts to quantify absolute value, in that the boundary conditions within which economic calculations occur are always changing. Even if we are successful in developing a plausible set of absolute commodity values for a given array of technical and utility trade-offs, we know that these values must change to reflect changes in manufacturing technique and personal preferences. Prospects for computing values that are both meaningful as units of measure, as well as properly expressive of changes in the economy's computational boundary, are therefore limited. We are, however, encouraged by observing that the familiar abstract categories, for which we now have physical units of measure, did not come to us fully realized and dimensioned. Strenuous intellectual proceedings have always been required to cast our sensory impressions into solid quiddities that might support rigorous study. Nearly 2 millennia passed before Aristotle's mashup of mass with velocity was disentangled to isolate our everyday notions of weight and momentum. Now familiar notions of humidity and barometric pressure required their separate distinctions before the idea of temperature acquired its distinct, quantifiable identity. Creating a unit of measure requires 2 specifications. 1. Where shall we locate 0? And 2. How big shall we make 1 unit? Such specifications are entirely arbitrary, so long as the theories they inhabit operate to preserve their constancy over time. These precepts can be exemplified by locating SF Econ's value unit in a hypothetical, global input-output structure. Our current proposal for a universal abstract value unit is the 1997 US dollar. The U.S. Bureau of Labor Statistics was producing rather complete input-output tables by 1997. The U.S. dominated the world economy at that time, and it was producing the most extensive array of products. 0 locates itself on our value scale in that everything in an SF Econ model is continuously evaluated in relation to the technologies operating during 1997. 1 unit of value is scaled by the US dollar equivalent, y sub 00, of all the economic activity that occurred on Earth during 1997. Y00 value tokens, the invariant output of the zeroth good in the zeroth or global economy at time 0, are always flowing through an SF Econ model. And our models operate to continuously distribute all of Y00 optimally among the economic sectors. Flows of the value unit are managed according to our video on the dynamics of the material circuit, not, as might be expected, by the dynamics of the financial circuit. Value is transacted in the manner of all the physical things to which it refers, and as is the case with those physical things, our global currency unit is tethered to a constant of theory, a matter of critical distinction from financial quanta, whose units of measure must be time-variant in order to effect stable adjustments to the economy's ever-changing boundary conditions. The GCU is also like physical quanta in that, as we shall see, it always has a money price computed for it, and it always has a production function composed of the production and utility trade-offs that define the commodities it represents. Thus it will be demanded in the manner of any commodity, and those demands can then be used collectively to continuously apportion the flows of our constant Y00 GCUs per year among the sector's valuations E sub I00. Each sector I will therefore be found processing a metaphysical measure of the value of its asset turnover, and, as we shall also see, this measure enables computation of the current absolute value of that sector's product. At equilibrium, a sector I's valuation, E sub I00, is the negative sense of the value of its asset turnover. E sub I00 is computed as minus the sum of each productive factor J's absolute value, psi sub J, times that factor's usage rate, E sub IJ0. Whether in or out of equilibrium, the value of a sector I's rates of asset turnover are sufficient to compute an operable absolute value, psi sub I, for its product. This computation references an intermediate variable, theta sub I0, composed from sector I's physical state variables and its utility parameters. Formulation of theta sub I0 links our notion of value to the hyperbolic mathematics that express production and utility trade-offs throughout the SF-econ system. Recall that a rate of monetary flow, zeta sub ik, is continuously being computed for each sector I in each economy K. Zeta sub ik brings in economy K's money prices, P sub jk, together with the sector ik's utility trade-offs, U sub ijk, so as to solve the polynomial factoring problem in mathematically closed form, and thereby determine Q sub ijk, the optimal rate for sector ik to use commodity J. Another rate of monetary flow, beta sub ik, is a formulation of sector ik's physical state, E sub ijk, its financial state, epsilon sub ik, and its utility parameters, U sub ijk. Beta sub ik was developed to hold place in our initial discussions on efficient prices in a dynamic context. Our videos on polynomial factoring and efficient prices can be found in the playlist on the SF-econ algorithm. Having launched a discussion of absolute value, we can now introduce a third rate of monetary flow, theta sub ik, to link sector ik's value with its utility function and economy k's money prices. Lowercase theta sub ik, denominated in the currency of economy K, relates to uppercase theta sub ik, denominated in value units by way of P sub 0k, the current and variable money price of one value unit in economy K's currency. Though the mathematics involved here are too complicated for presentation in this lecture format, it should come as no surprise that absolute commodity values, psi sub j, are a simple function of theta sub ik with the state variables and utility parameters associated with commodity j. Computational details are provided in our monograph on hyperbolic utility trade-offs. A link is provided in the show notes. Zeta sub ik, beta sub ik, and theta sub ik are continuously recomputed for each sector ik, and they vary independently during the operation of any SF-econ model. As our models approach the optimal stasis implicit in the utility parameters, these variables will resolve together into one and the same numeric quantity. As shown, the variables beta sub ik and capital theta sub ik operate to specify the money price, P sub 0 k, of 1 GCU in the currency of economy K. Regrettably, details of the sums involved in computing P sub 0 k are another of those specifications that are too complex for our lecture format. As the final step in creating SF-econ Model 0 is determination of a currency's value, as given by the inverse of P sub 0 k, nothing less than a complete understanding of the entire mechanism is required to grasp its relation of money to value. Once absolute commodity values, psi sub j, and currency values, P sub 0 k, are determined, money prices, P sub jk, can be computed as the product of a commodity j's value with the price of a value unit in the currency of economy K. It should be emphasized that our value calculations reference nothing akin to a market basket, the contents of which are never less variable than the phenomena they are intended to describe. Values are computed entirely on the basis of quanta having immutable physical units of measure, which is to say physical utility parameters, physical asset levels, and the fixed quantity y sub 0, 0.